Okay, I'll quickly revise what energy is. Energy is what? Energy is the capacity to do work. Okay, and
Yes, sir.
work is something that you can find by taking the dot product of force and displacement, right? Now, force
Yes,
is a
sir.
vector quantity, displacement is a vector quantity. Work is defined as the product of force and displacement in the direction of force, right? Product of force and displacement in the direction of force. Clear?
Yes, sir.
So it turns out that see, if these two vectors, you draw these two vectors, force vector and displacement vector, and if angle between the force vector and displacement vector is theta, then the displacement in the direction of force will be s cos theta. Are you understanding?
Yes, sir.
I'll just
Yes,
show
sir.
that. I'll just show. So force is defined as work is defined as product of force and displacement in the direction of force, right? Suppose this is your
Yes, sir.
force. I'll call it F bar.
Sir, if there is an angle between the force also, then its horizontal component will be
S cos
cancelling that, no,
theta.
sir?
Yeah. Wait, I'll show you. So this is displacement. Suppose this is S bar. Now this displacement has two components. What are those? One is this. I'll write in a dotted line, and the other is this.
Yes, sir.
So this is also other component. These two are rectangular components of displacement. Do you agree?
Yes,
Yes,
sir,
sir.
agree.
And angle between the force and displacement is theta.
Yes, sir.
So if angle between force and displacement is theta, what is the component of displacement in the direction of force? Tell me. I'll just show you the
Sir, can you
component.
repeat the question?
Okay, this is S cos theta.
Yes, sir.
The magnitude of this component is S.
S cos
Cos
theta.
theta.
This is
And the dotted line is S sin theta.
S sin theta. Now tell me what is the component of displacement in the direction of force?
In the, okay, S cos theta.
It is
S cos theta, sir.
So according to the definition of force, I can write W equals to
Fs cos
F
theta.
into S into cos
Cos
theta,
theta.
right?
Yes, sir.
Now, if you want to take the dot product of any two vectors, A bar dot B bar, then it is given by magnitude of A bar into magnitude of B bar
Yes, sir.
into cos of angle between them.
Yeah.
So if you
W
compare
equal to F dot S, actually.
W is equal to F dot S. F bar dot S bar. Now one more thing you remember, that dot product is a scalar product. That's why this is a scalar. Okay.
Yes, sir, got it.
But these two are vectors. Okay. F bar and S bar are vectors.
Vectors.
Clear, clear.
Yes, sir.
Now, okay, here all the notations. What do all W? What does F bar and what does F bar signify? That I have written here. Okay. Now,
Yes,
if
sir.
non-zero force acts on the body and it undergoes body undergoes non-zero displacement. Okay. If a non-zero constant force, F is applied on body, and if it undergoes a non-zero displacement S bar, then the work done is defined as F dot S. Clear? So
Yes, sir.
this definition is true. Which definition? Work done equals to
F dot S.
F dot S is true only if this is a constant force. Okay.
Work done is a constant. Yes, sir, got it.
No. Work done, not work done. Force is a constant vector.
Okay,
That means the magnitude of force is not changing with time.
got it, sir.
So if this is a constant,
That means its derivative should be equal to 0.
yeah, no, yeah. Anyway, its derivative is 0. But if it is not constant, what will you do?
Differentiate.
Integrate.
Integrate.
Okay.
What will you do? You'll write one equation first. Which equation? This equation. Okay, I'll write it in the next page. Okay. Actually, this is the thing, right?
Yes, sir.
Where is this page?
dw equal to df into s. That equation will integrate, I guess.
Okay, where is this page? Okay. Anyway, we'll leave this here.
Okay, sir.
Okay. The page is not showing. Okay, anyway. Now, see, if the angle between force and displacement is acute angle, then work done is positive. If it is 90 degrees, if it is a right angle, then work done is 0. And if the angle is obtuse, then work done is
Negative.
negative. Why? Because cos value is positive for, in the first quadrant, it is negative in the second quadrant, and it is 0 if the theta is 90. That
Yes,
I have
sir.
drawn here. That is very clear. Now here one simple question. A force of 25 Newton displaces an object by 12 meters such that the angle between force and displacement is 60 degrees. Find the work done. So it is very simple. Just use the formula Fs cos theta. Okay. So F is how much? 25 Newton and displacement is 12 meters. Okay, both are SI units. So your answer is how much? 25 into 12 into cos of 60, because angle between them is 60. Clear? Okay. So cos 60, everybody knows what cos 60 is. Tell me.
1/2.
1 by
1
root
by
2.
2. You just substitute that, you'll get the answer. So your answer is 150 joules. Okay.
Yes, sir.
Clear? Joules is the unit of work done. Okay. Now, this is another question. So we are applying 50 Newton force here. Can you see?
Yes.
Yes, sir.
So you are applying 50 Newton force. So I'll make it this color, different color. Okay, we are applying 50 Newton force. And we are applying such that the force is making an angle of 37 degrees with horizontal. Can you see that?
Yes, sir.
Yes, sir.
Here. It is making 37 degrees with horizontal.
Horizontal.
Obviously, this block will move. If it moves, it will probably move along the plane. Do you agree?
Yes, sir.
Yes, sir.
It may come up the plane also. When will it come up the plane? Tell me.
When there is no gravitational force.
No. There is gravitation. But what is the
Flipping.
no. In what situation will it lose contact? Its contact with ground.
Okay, sir. Got it. Friction is
Just
more than
think and
normal
tell.
reaction.
Very good. What? No, not friction.
Sorry, reverse, sir. Normal reaction is more than friction.
No. My question is, when will it lose contact with ground? When will it come in air?
N greater than or
normal
equal to
reaction is
mg.
More than friction.
No.
More
When
than
Greater than
gravitation.
mg.
See,
mg,
when normal reaction is positive, it will stay on ground. When normal
Okay.
reaction is
Negative, it will lose
negative
contact.
or zero, it will start losing contact. Do you agree?
Yes, sir.
Yes, sir.
Actually, there will never be a negative normal reaction. So you take this 50 Newton, you take two components of 50 Newton. What are the two components of 50 Newton? Tell me. One is this.
Yes, sir.
Another is
50 sine 37, 50 cos 37.
okay, correct. So tell me, what is 50 sine 37?
50 into 3 by 5.
50 into 3 by 5, 50 into
4 by 5.
4 by 5. So this is 50 into 4 by 5. Do you agree?
Yes, sir.
Yes, sir.
It's vertical. Okay. Now, just tell me, is that 50 into 4 by 5 enough to make normal reaction 0? See, this
No, sir.
is,
Weight is also acting downward.
weight is how much?
10 kg.
10 kg.
So it is 100 Newton, right?
Yes, sir.
Yes, sir.
I'll write here.
So it is
weight
enough,
is-
sir.
So weight is more, right? So it will not
Yes,
lose
sir.
contact. So
Yes,
I'm
sir.
just checking it, whether it will lose contact or not.
Yes, sir.
Because
Got it.
when the problem is given, I have to check whether it is correct or wrong. I cannot just assume that it is not losing contact. I have to check. Okay. If it was 1 kg, it
Okay,
would
sir.
have left, right?
Yes, sir.
If it was 1 kg, if the weight was 1 kg,
Yes, sir. Then it would have
it would have lost contact.
lost
Lost
contact.
Okay. So, okay. So this is displacing body by 40 meters. Now, what is the work done? Tell me. Work done is 40 meters into.
W equal to 50 into
uh,
what? 50 into 3 by 5 into 40.
okay. So basically, I have to take this component and do.
Yes, sir.
Yes.
So it is actually 30 Newton. 30 into 40 is the answer. 12.
Yes, sir. Got
1200.
it.
No, 30 into 40. No, not 30 into 40. Is it 30 into 40?
Yes, sir.
No. This is 4 by 5, right? This is 3 by 5, right?
Yeah, cos is 3 by 5.
Somebody told sine is 3 by 5, right? Sine 37.
Yes, sir.
Cos 37 is 4 by 5. So it is 40. Okay.
Yes, sir.
So 40 into 40. So it should be, I think, 1600. Right?
Yes, sir.
So answer must be 1600 Newton. Check it.
Yes, sir. It's correct.
Okay, fine. Now, work energy theorem. So work is change in kinetic energy,
Yes, sir. We proved already.
right? So here, did I do the work energy theorem?
Yes, sir. We did.
No, not here.
F equal to ma that we substituted in W equal to Fs.
Wait. Okay, anyway. So here we are applying work energy theorem and finding what the final velocity is. Okay, so this is 1600 joules, right? So it is
Yes, sir.
1600 into 2 by 10. So I think it is how much?
320.
So it is 320. Root of 320 is how much? I think 16 into 5 is no, not 16 into 5. 64
Yes,
into
sir.
5.
Yes, sir. I guess.
64 into 5, right?
Yes, sir.
320 is 64 into 5. So 64 comes outside and becomes 8. So it is 8 root 5.
8. So 8 root 5.
Okay. Anyway, I'll show you what kinetic energy is. I don't know why this. 1 second. Work power energy part 1. Okay. Okay. So anyway, we'll do that again. Fine. Now let me give you one more question here. See. So force is given in this style. Which style? In the form of IJK.
IJK.
So this is
We have to
force.
take out the dot product here.
You have to take out the dot product. And he has given initial position and final position here. Can you see?
Yes.
Final minus initial, sir. Displacement.
Displacement
Into
is final. Final minus initial. So it is 5 I cap minus j cap plus 3 cap minus I cap plus j cap plus k cap. We'll get the displacement, right? So displacement is
Yes,
final
sir.
position minus initial position. You got the displacement. After getting the displacement, force is given. You just check
F
the
dot
dot.
S then.
Taking the dot product is quite easy. You have to multiply the coefficient of I with coefficient of I, coefficient of j with coefficient of j, and coefficient of k with coefficient of k. That is your dot product. Clear?
Yes, sir.
And you will get the answer. So check what is the answer. Is it correct? What I have written? There may be some,
Okay, sir. Checking.
calculation mistakes. You just check. So displacement, is it correct? Yes, it is
Yes,
correct.
sir. Correct.
Okay. And what about dot product? Tell me.
Dot product also correct, sir. I check.
Dot product also correct.
Correct.
So okay. Anyway, I'll just make it clear. So this is how you do when IJK, in the form of IJK is given, your dot product will be actually easier to do, right? Because you don't need that cos theta and all. Clear? Okay.
Yes, sir.
So next problem you see. What is the next problem? Next the topic is for variable force. What do you mean by variable force? Tell me what is variable force?
The force which is changing with respect to time.
Respect to time, or it may change with respect to x also.
Yes,
Okay.
sir.
So when force changes, you cannot use that formula work done is equal to what?
So dW equal to dF into S. Integrating then.
Okay.
Yes, sir.
So dw you take a small work and you take a small displacement. So what was this? 4 into 2, right? Okay.
Yes, sir.
Okay, fine. So what do? You write dw is equal to fds, you integrate on both sides and you'll get clear.
Yes,
Okay.
sir.
Yes, sir. Clear.
Or instead of 0 to s, you can take from x1 to x2. x1 is initial position, x2 is final position. So instead of integrating with
Final
respect to
position.
s, you can integrate with respect to x. Clear?
Yes, sir. Got it. Hello.
Okay, can you hear me?
Yes, sir.
Give
Yes,
me one
sir.
second. Give me 1 second. Is anyone sharing screen?
No one, sir. Actually,
One
sir, two MLK79 are there, two devices. No, it's stopped.
Okay, 1 second. Okay, fine. Now here force is given in a different way. See, last time force given was some constant force. Can you see that? It was 10I cap plus 5J cap plus 4K cap. This is a constant force.
Yes,
It will
sir.
not change, right? With XYZ, it will remain same
Yes, sir.
everywhere.
Yes, it will remain.
But this force, if you see, it is changing with X and Y. At different place, you will have different value for force. Clear? Because it is a
Yes, sir.
variable.
Yes, sir. Clear.
Whenever this variable force is given, you have to integrate. So what I do is I find dw. Okay, an initial point I'm taking. For example, here see, I've given one example. At force at 0, 0, 0 will be 0. At 1, 1, 1, it will be 1, 1 I cap, 1 I cap, 1 J cap, 2, 2 K cap. If you substitute X, Y, Z coordinates here. Clear?
Yes, sir.
At 2, 3, 0, you'll have
Sir,
6, 9
this
cap.
F is given, no, sir? X, Y, I cap
Yeah,
plus
this is
Y
given in the
square J cap.
question. Yes,
Okay.
yes. Okay. Now what I do is I'll write W is equal to integral of FDR. Okay. Now what is dr? Dr is dx I cap plus dy j cap plus dz k cap. Can you see that?
Yes, sir.
Yes, sir.
Now here force I'll write as it is, and I'll write dr as dx I cap, dy j cap, dz k cap. That is the thing you have to remember. Okay. Now when you take the dot product, you multiply the coefficients of I and right. You multiply the coefficients of j and right. You multiply the coefficients of k and right. That is how you
Yes,
do
sir.
the dot product. Now you got 3 terms. You have to separate 3 integrals. Okay. So I have
Yes, sir.
separated these 3. Okay. After separating the 3, now I will integrate. But when I integrate with respect to x, I'll treat y as a
Yes, sir.
constant. Okay. So y is a
So
constant.
Y
So
will
it will
be
come out.
outside, kept outside.
It will be x square by 2. Here there is no y and z, so I need not worry. I'll write y cube by
Yeah.
3 here. Here there
Yes,
is
sir.
2y. Okay. So
So
I'm
2Y,
integrating with respect to
then
z.
Z square by 2.
By 2.
Clear? And
Yes,
limits.
sir,
What
got
are the
it.
limits? Initial position at the bottom and final position at the top. Clear?
Yeah.
Okay. So when I apply the limits, I apply the upper limit and I'll subtract,
Lower
lower
limit.
limit from the upper limit. So I'll write, 5 in place of x, 6 in place of y, and 7 in place of z, and put in the upper limit. And I'll
Yes,
write
sir.
x in, 1 in place of x, and 2 in place of y, and 3 in place of z, and I'll subtract the lower limit. I'll get the work done. Are you understanding?
Yes, sir.
So this is how the work is calculated if the problem is given in this style. Clear?
Yes, sir.
Okay. Now, for example, a particle displaces from 0, 0, 0 to 1, 1, 1 under the influence of this force. Okay. What is the work done? Same story again. All right. Work is equal to integral of FDR. In place of F, I'll
Yes,
write
sir.
this. In place of dr, I'll write dx I cap, dy j cap, and dz k cap. You're understanding this, right? Why
Yes, sir.
dr
Yes.
bar is
Yes, sir,
dx
got
by dy. In 3D, if you see dr bar, you move by dx in this direction, you move dy by in this direction, and you move dz in this direction. Clear?
Yes, sir.
So overall, it is dr. So that's why I'm writing this. So here, I'll now do the dot product. If I do the dot product, I multiply the coefficient of I with I, coefficient of j with j, coefficient of k with k. I'll get 3 terms. I separated the integrals in one step. Clear? So
Yes,
here,
sir.
when I integrate with respect to x, I put yz as constant. I write x square by 2. Here, x square is a constant. X square will come outside. There is no y, so 1 is left. The integral of 1 is y. Can you see?
Yes,
Yes.
sir.
Integral of
sir.
z cube, z square is z cube by 3. Again, I put the limits. I subtract upper limit
From the
lower
lower
limit
limit.
from the upper limit. So I'll get
Yeah,
11
I
by
got
6 joules. Now the thing is, this is given in meters. This thing is given in meters. These are all in meters, and force should be given in Newton. So you'll get answer in joules. Clear?
Yes, sir, got it.
Now one more example. There is a spring. In spring, suppose spring is oriented in x direction. Spring is oriented in
X direction.
Like the spring is oriented in x direction. It will extend along x direction, right?
Yes.
So here I'll draw a spring and show you. So spring is in x direction. Okay.
Yes,
So
sir.
if the spring is in x direction like this, okay. So F is what? Minus kx whenever spring extends
Yes.
from
It
its
will
main
be.
position. Okay. Clear? So it moves
Yes,
from
Yes,
x
sir.
comma x to the 0 comma 0 comma 0 to x comma 0 comma 0, because the spring is in x direction. I'm not worried about y and z. They'll remain 0 only. Clear?
Yes, sir.
Yes, sir.
Now I'm writing the formula again. Integral of FDR. Work done is integral of FDR.
FDR.
Now what should I write here? Should I write minus kx or plus kx?
minus, sir.
Minus k minus
Yes,
kx
sir.
if you are calculating work done by the spring. If you are calculating
Work done by the spring.
work done by the spring. If you are calculating work done by the external agent on the spring, then
Then
you have to take
positive.
Then it will be
positive.
positive.
Plus.
So whenever you hear the word work done, your first question must be work done by whom? Okay, work
By
done
the
by
spring.
gravity, work done by
Or
external agent, or net work done. Work done by
yes,
spring,
sir.
or work done by external agent, or net work done. Okay, so here work done will be minus half kx square. Work done by the spring. This is work done by the spring. How did you get? Simple. This is 0. This is 0. I'm not worried about these terms. So only this term remains. So it is minus kx dx. K is constant. K will come outside. Integral of x is x square by 2. And if I apply the limits, it will be minus half kx square. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir, clear.
By the spring. Okay? When you extend it by x. Clear?
Sir, J and K components are 0.
Yes, obviously.
Okay.
Now work done by the external agent will be half kx square. Can you see that?
Yes, sir.
Yes, sir.
Clear?
Yes,
Yes,
sir.
sir.
Obviously, work done by the external agent will be half kx square. Right? So
Yes, sir.
work done by external agent is always stored as potential energy. Morning, someone asked me, what
Yes,
is work
sir.
done equal to? Net work done is equal to change in kinetic energy, but work done by external agent is change in potential energy.
Change in potential.
I'll just explain that. Okay, wait a minute. Okay, so I'll explain that here. Wait. Here, see. Listen. Net work done. Tell me. What is net work done equal to?
Of potential energy plus kinetic.
No. Net work done
K final minus K initial.
is change in kinetic energy.
Yes, sir.
Clear?
Yes,
I'll
sir.
prove it, but just remember. Work done by external agent.
change in potential energy.
Sir, work done by, net work done is change in K. This is a work energy theorem.
Potential energy plus kinetic.
No. Wait. Work done by external
positive.
agent is change in potential energy. Clear?
Potential energy. Yes, sir.
Yes, sir.
Okay. I'll explain what this is. Listen carefully. Now, let me show you. Suppose you are taking a mass and you are lifting it. Okay, let us take a block. Okay, so this is a block. It is on ground, suppose. You are lifting it to some height. Let that be h. Okay,
Yes,
Okay.
sir.
basically you lifted this block through height h. Now we know that gravitational force will be downwards. So acceleration due to gravity will be down. Do you agree?
Yes, sir.
Yes, sir.
Now I am applying some force on this such that uh, it moves upward slowly in equilibrium, quasi-equilibrium. Okay.
Okay,
Yes.
sir.
See, if I apply force higher than weight, then what will happen? It will accelerate and
Lose
its kinetic
contact, yeah.
energy will change. Its kinetic energy will change.
Kinetic energy will change.
But if I don't want to change the kinetic energy, I just want to lift it up slowly. That means, when I stop my hand, that block should not have any velocity. It should be at rest only. Slowly, I'm bringing it up.
Got
Clear?
it, sir.
Okay. So, for lifting the block, lifting the block in quasi-equilibrium. Quasi means almost, because in equilibrium, if you start tell it is strictly in equilibrium, it will not move at all, right?
Yes,
Yes,
sir.
sir.
It will remain at rest. So F must be equal to, magnitude of F must be equal to mg, right?
Yes.
Yes, sir.
And if it is strictly correct, then it will not move at all. Because that force is 0, it will remain at rest. But it is almost equal. Clear?
Yes, sir.
Yes.
Now, work done by external agent, tell me.
Minus mg.
No, just look and tell.
F into H.
Yes. Tell me. Is
F into
F into
H.
H. You know why? F is in the upward direction, H is in the upward direction,
Upward direction. Yes.
and angle between them is 0. So it is cos 0 is 1. So it is F into H, right?
Yes, sir.
Yes, sir.
Yes, sir.
Which is implies work done by external agent is, I'll write WE, work done by external agent, equal to mgh. Do you agree?
Yes, sir.
Yes, sir.
That's
Yes,
why
sir. Agree.
change in potential energy is mgh. Okay.
Yes.
Yes, sir.
Okay, fine.
Sir, we cannot say like this. Work done by external agent equal to change in potential energy plus kinetic energy.
No.
Sir, always kinetic energy need not to be zero, right?
Which one?
Kinetic energy.
Okay, I'll give you that example. Don't worry. Here, in this case, tell me,
It is zero, sir.
which is 0?
Kinetic energy.
Okay, kinetic energy is 0. You know why?
V and U, there is no acceleration, right? So
No,
V and U.
I'll tell you. I'll tell you. Network done is work done by external agent plus work done by gravity.
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 Clear?
Yes,
Yes.
sir.
So tell me. Network done, tell me. What is WE? MGH?
mgh.
MGH.
What is work done by
MGH.
gravity?
and minus mgh.
Minus mgh. You know why? Mg weight is acting downward
Yes,
and
sir.
displacement is upward. It is 0.
Yes, sir.
Yes, sir. So it's at 0.
That's why change in
So, sir,
kinetic
always net work done is 0.
no in this problem.
Okay.
Clear?
Yes, sir.
Yes, clear.
Okay. Now here, when we talked about spring, right?
Yes, sir.
We talked about spring. Where is the spring? Here. Last. Here, work done by spring when extended by x is minus half kx square. Work done by external agent is what? How much?
Half kx square.
Plus half kx square. Okay, fine.
Yes, sir.
Yes, sir.
So what is work done by external agent? It is change in potential energy. So potential energy stored in spring is also half kx square, right?
Yes, sir.
Yes, sir.
And what is net work done? 0. That's why kinetic energy is 0 when you extend the spring to its
Yes,
extreme
sir, got it.
position. Right? Clear?
Yes, sir.
Okay.
Clear, sir.
If constant force are, if constant forces are acting, then you need not do this integral. Even if you do this integral, you'll get the same thing as you do the dot product directly. Clear? So that
Yes, sir.
I've done here and shown. That's all. So you'll get 1 here, you'll get 1 here, you'll get 2 here. Okay. So it will be 2x,
Yes, sir.
it will be 1y, and it will be 2z. Correct? So it is actually dot product of those two vectors directly, right?
Yeah.
So even if you do integral, you'll get the same thing. But whenever the force is not constant, you have to do integral. And when the force is constant, without integral also you can do. With integral also you'll get the same thing. Clear?
Yes, sir, got it.
Okay, fine. Now, actually we talked about work energy theorem and all before, but what is the kinetic energy? I'll tell you. Kinetic energy is the energy possessed by the body by the virtue of its motion. Clear? Now,
Yes, sir.
suppose expression for kinetic energy we want to derive. So if the force is constant, equations of motion are valid, right? V equal to u plus at, s equal to ut plus half at square, and v square minus u square is equal to 2s. They are valid, right?
Yes, sir.
Now here we'll assume a case where the force is constant. So acceleration will be f by m. Do you agree?
Yes, sir.
Yes, sir, agree.
So if I talk about magnitude of acceleration will be equal to magnitude of force by mass. Okay.
Yes, sir.
Suppose
Yes, sir.
initial velocity of body be 0. Initial velocity of body be
0.
final velocity be v. Now taking equation of motion, can I write v square minus u square is equal to 2s?
Yes.
Yes, sir.
So v square minus u square, u is 0 because initially it was at rest, is equal to 2.
Yes, sir.
A I can write f by m, right, by Newton's second law.
Yes.
Into s.
Newton's second law. Yes.
So what will happen? The m will go that side and the 2 will go and that side, and it will become half mv square. And here f into s will remain, but f into s is work done when the force is constant.
Yes, sir.
So kinetic energy is equal to work done. Clear?
Yes.
Great, sir.
Yes, sir.
Okay. So basically, whatever work you did is stored as kinetic energy in this case, and the expression for kinetic energy is half mv square. This is actually derivation for the expression for kinetic energy from work energy theorem. Okay.
Yes, sir.
Yes,
So
sir.
here you are just deriving the formula of kinetic energy. You are stating work energy theorem and you are deriving the formula of kinetic energy.
Kinetic
What is
energy.
formula of kinetic energy is half mv square. Clear?
Yes, sir.
Okay, fine. Now, if this is work energy theorem, here instead of taking initial velocity of as 0, I'll take initial velocity as u. So work done is f into s. So this is same derivation but in the opposite order. Okay, opposite way we are deriving. First I'm writing work done is equal to f into s. F I'm writing as ma from Newton's second law. Correct?
Yes, sir.
Now this is true only for this derivation we are doing by assuming that force is constant. Okay, so what is work done equal to? Half and 2. I can multiply half and 2 here, right?
Yes.
Yes, sir.
Half m into 2s, but 2s is equal to v square minus u square, right?
Yes.
Yes.
So work done is equal to half mv square minus half mv
Yes,
square,
sir. Which is
square
K final minus K initial.
K initial. So work done is equal to change in current. Clear?
Yes, sir.
Yes, sir.
Now, sometimes people get doubt. Okay, why do we take work done as, change in kinetic energy plus potential energy then, right?
Yes, sir.
Yes, sir.
Problems we take work done as change in kinetic energy plus potential energy, right? So actually potential energy is nothing but work done by gravity. Okay, I'll show you. So change in kinetic energy. So this is change in kinetic energy. So actually this is the correct work energy theorem. Just to understand. Change in
Kinetic energy.
kinetic energy. So there is okay. So actually there is okay, one example if I give you'll understand. Work done by external agent in quasi-equilibrium process is equal to change in potential energy. Clear?
Yes.
Yes, sir.
Okay, that same thing I have done here. Okay, so total work done is mgh minus mgh, it is 0. So change in kinetic energy is 0. Work done by gravitational force is minus mgh. Work done by external agent is plus mgh. Okay,
Yes, sir.
so this is change in potential
Net
energy.
work done is 0.
This is change in kinetic energy. Okay, so this is change in potential energy,
Potential energy.
and this is change in kinetic energy. Clear?
Yes, sir.
So don't get confused here. So net work done is change in kinetic energy, and work done by external agent is change in
Potential energy.
potential. Okay, clear?
Yes.
The law of conservation of energy says that net energy is constant for any system. Okay, so
Yes, sir.
some common types of potential energies are gravitational potential energy, electrostatic potential energy, and potential energy of a loaded spring, which you have already seen, half kx square, right?
Yes, sir.
Clear? So here that law of conservation of energy is given, and some explanation is given. You can just read that. Okay, I'll give
Yes,
you
sir.
one problem you do here. I'll give you one problem you do. Okay. At certain height, h, at certain height, h, kinetic energy is 3 times potential energy. For a particle, for a projectile, for a vertical projectile, for a
Vertical. Vertical projectile.
Vertical projectile.
find its maximum height. Do this problem. How to do? How to do this problem? Tell me. See, whenever problem is given, just write
V
down.
square,
Tell me.
V square by 2G आ रहा
V square by 6G.
2G
देखो आंसर क्वेश्चन में सिर्फ एक ही वेरिएबल दिया स्मॉल h, तो आपका आंसर भी स्मॉल h के टर्म्स में ही आना.
okay
Okay.
okay sir
How do you do this problem? So it is actually very simple. See, watch carefully. You can do some long method with so many formulas and all that stupid things you can do, but no need. So watch carefully. See here. Can you see?
yes sir
Suppose this is the mass of particle that is starting from ground. This is the ground. Can you see? This dotted line is the ground. So this is the bottommost point. Now it will go to some maximum height. Okay, let it be this. Let this be some maximum height. Okay.
Okay, sir.
Now this is at some other height. while we are seeing, because at maximum height kinetic energy will be 0. That means the given height is not maximum height, that is for sure. Okay,
Yes.
so this is the height given, and here kinetic energy is 3 times potential energy. Kinetic energy is
3 times potential.
3 times potential energy, and I can guess blindly that that must be closer to ground, because kinetic energy is higher than potential energy. That means mostly it
sir.
is kinetic energy, correct?
Yes, sir.
Yes, sir.
So at this point, what will be total energy? Tell me.
Kinetic energy plus 3 potential energy.
Total energy equals to, no, kinetic energy plus potential energy. That's all.
Okay.
Total
Okay.
energy क्या है? Total energy क्या है? बोलो.
Kinetic energy plus
Potential
potential.
energy plus kinetic energy.
फिर kinetic energy को potential energy में लिखना 3 potential.
Very good, very good.
फिर 4
4
potential
के ही आ जाता.
4 PE आता.
Therefore, T is कितना?
4 PE.
4p.
Why did you write everything in potential energy? Tell me.
Kinetic energy is maximum.
Because velocity is not given, height is given.
Yes sir.
Yes,
So it is
sir.
4
mgh
mg
लिख दे सकते हैं.
h, correct?
Yes sir.
Yes, sir.
Yes, sir.
Now problem is done. What is the answer?
Total energy will be a constant in whole projectile.
Okay, very good. At the
Yes.
highest point,
Hi.
total energy is potential energy dash. I'm writing dash here because, correct? Plus
Yes.
kinetic
Yes,
energy
sir.
dash, correct?
Yes, sir.
Implies total energy should remain same, right?
Yes sir.
Yes,
So
sir.
TE dash must be equal to TE. Therefore, see, I need not write all these steps just for explaining. I'm writing. I know the answer already. Okay. See, what is total energy dash? Correct?
Yes, sir.
4 mgh, right? Is equal to a
Yes,
topmost
sir.
point, it is mg capital H.
Yes sir. 4.
Yes, sir.
Therefore, answer is
Sir, actually it should be reversed. mgh equal to 4 mgh, I guess.
no.
4H sir.
H equals to 4h.
Clear?
Yes sir.
Okay.
Yes.
sir.
Yes, sir.
Basically, what we are doing, we are just applying law of conservation of energy and we are doing it properly. We are not doing anything stupid. Okay. So we can do in a long method also, but I don't want to do. One more problem. Do. For an oblique projectile. Oblique projectile. Potential energy at the, sorry, kinetic energy at the highest point. Kinetic energy at the
Highest point.
is half. All right, is half of the kinetic energy at the point of projection. Okay.
Yes, sir.
Find the angle of projection. So when he doesn't say anything, you have to assume that that angle is asking with horizontal. Okay.
Yes, sir.
Unless or otherwise he's saying that find the angle with vertical. Okay, how to do this?
KE final is equals to half KE initial.
Okay.
Then sir answer
Sir,
कैसा
its velocity is 0 at the highest point.
No. What is the velocity of projectile at the highest point?
at the highest point?
No. This is not a vertical projectile.
Okay.
That's why he's asking the angle.
Okay, got it,
Horizontal.
sir.
Components लेना क्या sir?
Where is angle 45?
Yes, and answer is 45. How? See, at highest point, what
U
will be
cos
the
theta.
velocity? U cos theta, right?
Yes,
Yes,
sir.
sir.
देखो भाई ऐसा लॉन्च करे ना, इनिशियल
Yes, sir.
वेलोसिटी क्या है बोलो? U
U
है,
है.
इसके दो कंपोनेंट्स है, एक u cos थीटा है और एक है u sin थीटा. क्लियर?
Yes, sir.
Yes, sir.
जब ये हाईएस्ट पॉइंट पे जाता क्या जीरो होता? क्या जीरो होता भाई?
Potential.
नो, u
U
sin theta
sin
zero.
theta.
U
U
sin
sin theta 0 हो जाता.
u cos theta वही रहता है, it doesn't change because there
हाँ,
is
sir.
no force in that
Yes.
direction.
So you signed it out.
U sin
Okay.
theta changes.
So basically what happens is this u sin theta will slowly decrease and become zero, and it will become negative after highest point. Clear?
Yes, sir.
Yes,
Yes, sir.
Yes, sir, clear.
If you remember, ux is equal to u cos theta,
Uy is equal to U sin theta.
U sin theta.
uy is equal to u
You
sin theta,
signed it.
Yes, sir.
and vx is equal to u cos theta only.
U cos theta.
Vy is equal to u sin theta minus d. Clear?
Yes, sir.
Yes,
Yes,
sir.
sir.
Just revising this. No answer. Problem is simple. Just substitute, you'll get the answer. Kinetic energy final is how much? Half u square,
U-
sorry, m into u square cos square theta,
Cos
right?
theta.
It is half of initial kinetic energy, which is m u square. Because
Yes,
see,
sir.
initial velocity was u, right?
Yes.
Yes, sir.
From here you can just solve in one step. You'll get what is cos square theta equal to? Half
1 to
plus cos theta equal to 1 by root 2. Clear?
One.
Yes, sir.
45.
45.
Sir, it is half of half mu square, right?
Barabar, correct? Half will cancel. Yeah. There.
1/4 mu square होता फिर वो.
ठीक है. There is one more half here. That
Yes,
is
sir.
half from the formula, and this is half. So basically, your answer is 45.
45.
Yes, sir.
Clear?
Yes, sir.
Yes, sir.
Okay. Theta is pi by 4, right?
Yes, sir.
Clear?
Yes, sir.
Okay. So there will be some other problems involving this oblique projectiles and work power energy. Now here we are looking at a spring. Now the spring is being extended by x from its mean position. Can you see that?
Yes,
Yes.
sir.
Yes, sir.
Okay. Now we are extending this spring by x. So what will be F external equal to? F by the spring. F external must be equal to F by the spring. If you want to do this, move this spring by in quasi-equilibrium process. Are you understanding?
Yes, sir.
So the magnitude of F spring and the magnitude of F external must be equal, so that the length of the spring is extending in what? Equilibrium. Can you see that?
Equilibrium. Yes, sir.
Now it is true while you extend the spring as well as when you compress the spring. Clear?
Yes, sir.
Okay. While compressing also, your external force should be towards compression of spring, and your spring will be pushing against it. Clear? While elongating also, same story. Both will be in equal and opposite direction. Okay. But
Okay.
what is spring force? Spring force is minus kx, right?
Yes, sir.
Yes.
Why?
Yes,
Because if you pull it it will oppose. If you push it, it will oppose. That means always force is in the opposite direction of x. That's why that minus sign will come. And more you pull, more it will oppose. Less you pull, less it will oppose. That means force is proportional to x. So that minus sign will come, and the proportionality constant is k. Clear?
Yes,
Yeah.
sir.
Yes, sir. Clear.
Fine. Anyway, so what will be okay? So based on this, you can do one problem. See, here I have given a spring. Okay. Length of the spring is 10 centimeter on applying 8 Newton force and 12 centimeter on applying 10 Newton force. Find the natural length of the spring. Okay. Find the natural length of the spring. How will you do this problem?
F.
Huh?
F1.
So see, F1 is equal to 8 Newton, F2 is equal to 10 Newton. Okay. When you are
Yes, sir.
applying, 8 Newton of force, its length was 10. So the the natural length, let me call it L naught. Okay. So the extension will
Yes,
be
sir.
10 minus L naught.
Yes, sir.
Can you see that?
Yes, sir.
And x2 will be 12 minus L naught.
Yes.
Okay. So you know that F1 is equal to kx1 and F2 is equal to kx2. So F1 by F2
Yes,
is equal
sir.
to kx1 by kx2. So F1 by F2 is x1 by x2. Clear?
Yes, sir.
So 8 by 10 will be equal to 10 minus L naught by 12 minus L naught.
Yes, sir. Got it.
So if you take the common, what will you get? 8 into, tell me, 12 minus L naught. Cross
L equal to
multiply.
2 centimeter. Yeah.
Yes. It is how much? 10
10 into 10
L.
minus L.
10 into 10 minus L naught. Clear?
Yes, sir.
Yes, sir.
So after that, it is just solving. You multiply. So you'll get this. Okay. So 12 into 8. 12 times 8 minus 8 L naught is equal to 10 times 10 minus 10 L naught. You bring L naught to one side. So what will you get? 10 L naught minus 8 L naught equal to 100 minus 96. So L naught is equal to 2 centimeters. Clear?
Yes, sir.
Yes,
Clear.
sir.
Okay. Okay. I'll give you one more problem. Same problem. You do. Okay,
Okay,
let
sir.
us check the extensions. For 10 centimeter extension was 8. For 12 it was
10.
how much?
10.
10. So see, it is proportional to the forces applied, right?
Yes, sir.
Yes, sir.
Okay, fine. I'll give you next problem. You just tell me. A spring has length of 32 centimeter on application of 400 Newton and has length of 30 centimeter on application of 200 Newton. Find the natural length of the and spring constant. How to do this? You can just look and guess answer. You can just look and guess.
Natural length is 2 and
No. See, when you apply 400 Newton, its length was 32 centimeter. And when you apply 200 Newton, its length was 30 centimeter. Clear?
Yes.
Yes, sir. Clear.
So you can just look and guess. See, you are
28 centimeter.
how much? 28. How did you get? See, it is clear now. For 400,
Yes.
whatever extension is, for 200, it should be half of it.
Yes, sir.
देखो भाई 200 पे अगर x से हो रहा तो 400 पे 2x से होना.
Yes.
Yes, sir.
तो थोड़ा गौर करो, ये 30 है और वो 32 है, तो ऑब्वियसली 2 सेंटीमीटर से एक्सटेंड हुआ होगा. 200 लगा है तो और
Yes,
400
sir.
लगा है तो 4 से हुआ होगा. तो ऐसा भी आंसर करने आना आप लोग. क्लियर?
Yes,
जस्ट
sir.
बाय रेशियो एंड प्रोपोर्शन. क्लियर? So 400 पे 32 है, 200 पे 30 है. तो अगर बेसिक मेथड से करे प्रॉपरली तो भी वही आता आंसर, बट इतना करने की जरूरत पड़ना नहीं. ठीक है,
Yes, sir.
यस सर.
क्लियर? तो
सर
बेसिकली
उधर
मैं क्या
नेचुरल लेंथ क्या है वो समझ में नहीं आया सर.
28 है नेचुरल लेंथ.
नहीं वैसा नहीं, मतलब एक्चुअली जनरली नेचुरल लेंथ क्या है.
स्प्रिंग पे जब कोई फोर्स नहीं अप्लाई करते तो उसकी जो लेंथ रहती वो नेचुरल लेंथ है.
ओके.
फोर्स लगाने के बाद जो बढ़ जाता है ना, फॉर एग्जांपल नेचुरल लेंथ 28 है इसका, फोर्स लगाने के बाद 2 सेंटीमीटर से एक्सटेंड हुआ तो 30 हो जाता है.
ओके समझ गया सर.
क्लियर? नेचुरल लेंथ
Yes,
मतलब
sir.
अनएक्सटेंडेड लेंथ.
ओके.
क्लियर?
यस सर क्लियर.
ठीक है ना?
यस सर.
Yes, sir.
तो मैं ये गेस करके करो बोला. 400 पे 32 था, 200 it is 30. So you can just understand that whatever extension is on application of this force, compared to that it should be double on the application of this force. Clear?
यस सर.
Yes.
So guess करो, just देखो यहाँ पे 32 है, 30 है, तो obviously 28 से 30 हुआ होगा और ये 28 से 32 हुआ होगा, तो ये 2 सेंटीमीटर होता, ये 4 सेंटीमीटर होता.
Yes.
यस.
Clear? Okay?
Yes, sir.
यस सर.
पोटेंशियल एनर्जी स्टोर्ड इन स्प्रिंग क्या होता? अगेन वेरिएबल फोर्स है क्योंकि एक्स से चेंज हो रहा, तो एफ 0
Yes.
से एस, एफ डी एस करे, 0 से एक्स करे, के कांस्टेंट है बाहर आ गया, एस अंदर रह गया. व्हाट इज इंटीग्रल ऑफ एस विद रिस्पेक्ट टू
एस
एस?
स्क्वायर बाय 2.
स्क्वायर बाय 2 डाल दिया, फिर 0 टू एक्स करे तो क्या आया?
तो एक्स स्क्वायर
Half
बाय
kx.
2 आ जाता.
तो वर्क डन बाय एक्सटर्नल एजेंट इज व्हाट? चेंज इन पोटेंशियल एनर्जी बोला ना,
यस सर.
Yes.
तो डोंट गेट कंफ्यूज. वर्क डन बाय एक्सटर्नल एजेंट इज चेंज इन पोटेंशियल एनर्जी. क्लियर?
Yes, sir.
यस सर क्लियर.
Our potential energy is this. Clear?
Yes,
Yes,
sir.
sir.
Okay, half kx squared. So this is called potential energy of a spring, or potential energy stored in a
Stored in spring.
extended spring. Clear?
Yes, sir.
क्लियर सर.
Okay. Now you can rewrite this formula. You can multiply and divide by k. So you'll get k square x square by 2x, 2k. Clear?
Yes, sir.
So same formula. I'm just multiplying and dividing by k. So I'll get k square x square in the top. So it will become f square, right? Because kx equal to f, right?
Yes, sir.
Yes, sir.
यस सर.
Or f equal to minus kx, whatever it is. Anyway, it is square. So we need not worry. Clear?
यस सर.
Or
Yes.
we can, potential energy is equal to f into x by 2 also. How? You can write this as what? Half into
kx means f we can write.
kx is f, right?
Yes sir.
Half into kx into x. So this is f, right? So it is
Yes,
f into x by 2. So this is also the formula.
Yes sir.
In fact, if you see, before extension, force applied is 0. After extension, force applied is f, right? Slowly we are increasing force from 0 to f.
Yes
What
sir.
happens? F by 2, right?
Yes, sir.
Yes sir.
Yes,
So
sir.
work done can also be written as average force into displacement. So F by 2 into x. That is also one way of writing the potential energy or work done. Clear?
Yes, sir.
Yes, sir. Clear.
That will not be always true. Average will not always be equal to, initial plus final value by 2. It will be only true if the force is increasing constantly, linearly. So fortunately,
Yes, sir.
it is linear. That's why you got average. Clear?
Yes, sir.
Yes sir. Clear.
सर क्लास की टाइमिंग कब तक है? 5.
हाँ. 5.
ओके सर.
Clear? अच्छा, one more thing. अगर फोर्स में डबल कर दिया तो एनर्जी स्टोर्ड क्या हो जाती स्प्रिंग में? देखो यहाँ पे ये फॉर्मूला देख के बोलो. अगर जो एक्सटेंड कर रहे हैं फोर्स का वो अगर मैं डबल कर दिया तो एनर्जी क्या हो जाती?
2fx square by 2k.
तो 4 टाइम्स हो जाती. इट बिकम्स 4 टाइम्स.
हाँ.
And 4 times. Yes.
If I triple, it will become 9 times. Clear?
9 times. Yes.
Now I'm asking you one question. Listen carefully. If the force is increased by 100%, what will be the percentage increase in potential energy?
Can you repeat the question, sir?
If the force applied to extend the spring is increased by 100%, what will be the increase in percentage of potential energy stored?
50%.
No. See,
Same, sir.
200%.
no,
100%, sir.
I'll show you.
It will
Force
be
is
increased
increased.
same, I guess.
देखो, force is increased by 100%. So that means F will become F plus F because 100% of F is F, right?
Yes, sir.
तो force कितना हो गया? 2F हो गया, right? तो potential
Yes,
energy
sir.
क्या हो जाती? 4PE हो जाती, right?
Yes.
Yes, sir.
4PE, it became 4PE, but the increase is 3PE.
Yes.
So increase
300%.
300%. Increase is 300%.
300%.
Clear?
Yes, sir. Yes,
Once
sir.
again,
I didn't get.
If the force is increased by 100%, force is increased by F.
Yes, sir.
मैं यहाँ पे बता दूँ. Okay. Where is it? Approximations. Okay. So, if the force is increased by 100%, I'm writing here. See,
Okay.
implies F dash is equal to
F
F
plus F.
plus F.
F
is
plus
equal
F.
to F. Clear?
yes, sir.
Yes,
Yes.
sir.
Acha, first potential energy was how much? F square by 2k,
F by
right?
2k. Yes, sir.
तो PE dash क्या हो जाता है बोलो?
F plus F whole square by 2k.
वो तो 4f square by 2 के है.
हाँ. तो कंपेयर करें तो पोटेंशियल एनर्जी 4 टाइम्स हो गई.
Clear?
Yes, sir.
Yes, sir.
So
P
here,
dash equal to 4p.
clear?
Yes.
Yes,
Yes, sir.
Now here, what is PE dash? Clear?
Yes, sir.
Yes, sir.
PE plus 3PE, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
Potential energy. So, what is the conclusion? Tell me. Has increased by
300%.
300%. Clear?
Yes, sir.
Next. F is increased by 10%. Okay. So F
Yes,
dash,
sir.
follow. F plus 0.1 F because 10%
Yes, sir.
is 0. So here what will you write? F dash is equal to 1.1 F, right?
1.1 F whole square
Okay.
by 2k.
Okay.
नहीं,
Okay.
yeah.
So first you write potential energy. Correct?
Yes,
What
sir.
is final potential energy? P prime equal to F dash square by 2k. Do you agree?
Yes,
Yes,
sir.
sir.
Which is 1.1 F.
Sir, it will be increased by 21%.
2k.
Yes.
Whole square.
It will increase by 21%, right?
Yes, I got it.
I'm writing whole square here. Clear?
Yes, sir. Clear.
So what is potential energy dash? 1.21 F square by 2k, correct?
Yes, sir. Yes, sir.
Which
Yes,
is 1.21 initial potential energy. Do you agree?
Yes, sir. So 1p plus 0.21p.
Yes. So PE prime can be written as PE plus 0.21 P.
Yes, sir.
So 0.21 P is
Nothing but 21%.
PE increases by
21%.
yes, sir.
clear.
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 Now there is something called approximations. If these percentages are small,
All.
then you need not do all this. You can directly tell the answer. I'll tell you what that approximation is, and it will be coming in every chapter. Not only in work power energy, but in every
Sir,
chapter.
in maths we did area same game, sir. Same problems.
Okay.
Yes, sir.
So I'll just quickly revise that. Area of a circle is pi r square. Now, if
Yes,
I
sir.
take derivative of a with respect to r, what will I get? dA by dr is equal to pi is a constant and derivative of 2r is r square is 2r. Clear?
Yes, sir.
Yes, sir.
Yes,
So
sir.
dA is 2 pi r dr.
Yes.
So if I divide both sides by a, what will I get? So on the left side I divided by a, but on the right side I divided by pi r square, right?
Yes,
Both
sir.
are same.
Yes.
So I got dA by a here. Here I pi and pi cancel, 1r and r cancel. I got 2 dr by r. Okay. So
Yes,
change
sir.
in percentage of area or fractional change in area is twice the fractional change in
Radius.
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 That you can just directly tell by looking at the power. So if
Yeah.
this increases by 1%, this increases by 2%. If this increases by 2%, this increases by
4%.
this
4%.
increases by 3, this
9%.
also increases by 6.
9%.
6. Just
6.
multiply by 2.
Okay.
Okay.
So if increases by 5%, this increases by 10%.
10%.
10%.
This is true only for small changes with below 5%. More than 5%, you have to do it properly. Otherwise, you cannot apply this. Clear?
Sir, if we consider volume, if volume increases by 1%, then it will be increasing by
Here.
3%, no, sir?
Yes. Volume is 4 by 3 pi r cube. Derivative of
Yeah.
volume with respect, this is volume of a sphere. Is 4 by 3
Got
pi
it, sir.
into 3r square divided by volume on the both side. Here V I am dividing, here 4 by 3 pi r cube I am dividing. So I'll pi will cancel, 4 by 3 pi, 4 by 3 pi, 4 by 3 pi will cancel. Sorry, the 3 will not cancel. Pi will cancel. So this r square and r cube will cancel. So dv by v is equal to 3 dr by r. Correct?
Yes,
Yes.
sir.
So you understood the story, I guess.
Yes, sir. Got it.
Whereas see, time period of pendulum is root L by G, right?
Yes, sir. This also be
So dt by dl
yes, sir.
is 2 pi by root G is constant. So derivative of root
Root L is 1 by 2
1 by 2
into
root L.
L into 1 by 2 minus 1.
1 by 2 root L, right?
Yes,
Yes,
sir.
sir.
Now I'll separate the variable dt and dl. Okay. And then I'll divide
Yes,
by
sir.
t on both sides. Here also t, there 2 pi into under root L by G. Clear?
Yes, sir.
Sir.
So here 2 pi will cancel. Root G
Yes,
will
sir.
cancel. And this root L into root L will become L. So it is half into
Yes.
dl by L. Clear?
Yes, sir.
Yes,
Because
sir.
the power is half, approximation is also half. So if
Yeah,
the
got it, sir.
length changes by 3%, time period changes by 3.3 by
3
2%.
point. Yes,
3
sir.
by 2. Clear? You understood the
Yes,
story,
sir.
right?
Yes, sir. Understood.
And if there are more than one variables, like cylinder, for cylinder, what is cylinder? Huh?
Pi
What
r
is the
square
volume?
h.
What is volume of cylinder? Tell me.
Pi r square h.
Yes, sir. Pi r square h. Cone is 1 by 3.
Okay. Tell me. V equals to pi r square h, right? Now
Yes,
here
sir.
I
Yes,
cannot
sir.
take the derivative with respect to r or with respect to h because there are two variables here. So I'll do implicit derivative, implicit differentiation.
Okay.
So implicit differentiation, if I do, I'll get dv here on the left hand side.
Yes, sir.
Clear?
Yes, sir.
dv, and I'll apply product rule. In product rule, I'll write first variable as it is, and I'll multiply by the derivative of the second variable, plus
Yes, sir.
I'll put the second variable as it is, and I'll multiply with the derivative of the second. Second is what?
Second.
2r into dr. Do you agree?
dr. Yes, sir. Got it.
Now divide by volume on the both sides. Divide by volume on both sides. Divide by both sides.
So
What will you get?
differentiating with respect to.
Nothing. Implicit
Okay.
differentiation.
Okay. Implicit differentiation. Got it.
So it is dv by v equals to pi r square dh by what should I do?
Pi r square
Pi
h.
r square h.
Pi r square cancel. So sir, power of h is not there. That's why the change in volume is same as change in height.
No. What is dv by v?
dh
is
plus
H by h.
dr by h
R.
R.
by yes sir r.
So this is as expected because the power of r was 2 and the power of h was 1.
Yes, sir.
Understood, sir.
Clear?
Yes,
Yes,
sir.
clear.
So if there are more than one variable, according to their powers, you have to add all the errors and approximations. Clear?
Yes, sir.
Yes sir.
For example, here, where is this? Some f of x is x power 5, y power minus 3, and z square. So, clear?
Pi dx by x
Yes, sir. Clear.
minus
there are
3y
three-
minus 3 dy by y
So
2
see,
dz by z.
okay, so here percentages are given +1, +2, and -3. Okay,
Yes, sir.
1%. Second one was 2%. Third one was -3%.
-3%.
So according to their powers, you do 5 into 1
Got it sir.
plus -3 into 2 plus 2 into -3. Clear?
Yes,
Yes,
sir.
sir,
7
clear.
minus
Change in f
7%.
is -7%. Clear?
Yes,
Yes,
sir.
sir.
Yes, sir.
Sometimes he will give you error. Error, when he gives you error will always be plus or minus. It will not be plus or it will not be minus. Error will be plus or minus. Okay? When error
Yes,
is
sir.
given, don't worry about this negative sign. You add all. For example, here, if error is 1%, error is 2%, and error is 3%. Suppose.
Yes.
Okay.
So error will not be positive or negative. It will be plus or minus, measuring error. Okay?
Okay, sir.
Yes.
Now when you do you don't consider this minus because you have to find maximum error. Maximum error comes when worst case scenario, when all add up, not when all cancel each other's error. Okay?
Yes.
So
Got it,
maximum error will be 1 into 5 plus 3
3
into
into
2
2
3 into
plus
2.
2 into 3.
2 into 3.
So here I'm
Got
not
it, sir.
considering the minus sign here. Can you
Yes.
understand that?
Yes,
Yeah.
sir.
Yes, sir.
Whenever error
Yes,
whenever error is asking, you do this.
Okay, sir.
Okay, sir.
Okay, fine. Yeah, the same problems are given.
Yes, sir.
Yes, sir.
Okay, we'll continue tomorrow. You just go through
Okay,
this
sir.
Okay, sir.
Okay, sir.
Monday.
Thank you, sir.
Okay.
सर
Sir?
बोलो.
काइनेमेटिक्स के वो कल जो क्लास लिए थे ना 6 o'clock
हाँ.
के बाद
हाँ,
उसकी
हाँ.
रिकॉर्डिंग करेगा.
नहीं उसकी नहीं करा, वो बाहर से लिया था.
ओके,
आज भी
तो
ले
बता
लो.
देते हैं अब्दुल रहमान.
ठीक है सर. आज की तो भेज डालो. शुरू की क्लास मिस हो गई मेरी 15 मिनट्स की कुछ.